Alright, here we are, and we're going to find all the key features of our graph. Okay, and what I'm going to do is I'm going to do am I ready, question number 2. And what we're going to do is we are going to realize that when we graph a real world situation that is a quadratic from a situation, we want to find 3 key points. The first one being the y-intercept, the second one being the x-intercept, and the third one being the vertex or the maximum. Now, a lot of times it's going to be a maximum, but not always. It could be a minimum. It just depends upon the situation. Now, I've entered in the equation from number 2, and what we're going to do is analyze it, and we're going to try and have an idea of what to do when we're given the standard 10 by 10 window and how we're going to change this value. Okay? So how we're going to look at this first is we're going to go to the window, and we need to change the graph. Now realize to the right of my calculator you can see the graph changing as I change the different x-min and x-max values. On the x-min, I want it to have a little room on the left side so that I can see a little bit to the left. So I'm going to change that x-min to a -2. That means that the leftmost x value that will show on my window will be -2. Now my x-max, I'm going to change that to what I think is appropriate. Now in this situation, it is a football that is being punted in the air, and so we need to realize that we need to figure out, okay, how long is it going to take for that ball to come down? Realistically, I would say 5 seconds. So we change our x-max to 5 seconds. That could be different. I might have to change that, but we'll see. I hit enter. And you can see on my graph below that it actually doesn't look too bad. It looks pretty good. I don't have too much room here on the right side, so that x-max was a pretty good choice. Now, the y-min, I'm going to leave that at -10. I want some room on the bottom so that I can see it. Remember that we're only going to look at positive x and y values. We are not going to look at anything different than those x and y values. So, what I really need to look at changing is the y-max. Well, how many feet in the air do we really think that a football could be punted? I would say let's start at 50. And we will go by 5s if we're going from 0 to 50. On my graph down here to the right, you see that there's a lot of room on the top, which means that my y-max is way too big. So I need to change that to about, let's try 30. Let's see if that helps. And it does. You can tell that it definitely helps and that it now uses much less room. Now, if you really were inclined to, you could change the window and you could change the x-max to 3 or 4 just to give yourself less room on the right-hand side. It's really up to you what you choose. Now, what we're going to do next is we're going to find all the key points and go through the different calculator presses. So what I'm going to do first is hit trace. And hitting trace allows me to move along the curve and find any points along the curve. Now, it does have a random jump effect on it, but you can find any points. What's also nice about the trace function is that you can substitute different x values in to find its y value when x is that value you chose. So when we have a y-intercept, we always know that x is 0. So what we're going to do is substitute 0 for x, and then hit enter. And we get 4. So then we know our y-intercept is 4. And to us, that should be no surprise because of the fact that our c value in our equation was positive 4. Next, what we're going to look at is substituting different values when we're asked, okay, what is the height of our object after this amount of time? Well, we can do the same thing, just substitute different x values. So if I were asked here a question, what is the height after 1 second? Enter in 1 for x, and it gives you the value for y, 28 feet. You could do that for any time period. You could do it for 2 as well, or you could try 3. But again, 3 looks like it doesn't make sense to us because the y value is negative, so it wouldn't really make sense to look at that y value. What we need to find next is the maximum. So we need to find the maximum height. What we're going to do is we're going to go to the second calculate menu, and we are going to go ahead and we're going to select maximum because our vertex is a maximum point. So we're going to hit yes. Now it's asking me for a left bound first. We need to first realize that there's the same key presses every time you're finding a maximum or a 0. First you want to hover over the point. After you hovered over the point, what you want to do is you want to move 3 clicks to the left. So 1, 2, 3, and then hit enter. Now you know that you've established a left bound that is to the left of the vertex. Now it's asking you for a right bound. So what you want to do is go back to the original spot you were at, 1, 2, 3 to the right, and then go 1, 2, 3 to the right again to get your right bound. Hit enter. Now you can guess if you want to, you don't have to, but it's always good to guesstimate and try and see what you think the vertex should be. So here I think it's going to be close to around 1.2 and 29 it looks like. And when I actually find the maximum, that's exactly what it was close to. It was 1.25 seconds, it's 29 feet in the air. So it's nice to know that I can guess and somewhat figure out what the maximum is going to be. Now, the next piece of this will be if I hit second, trace, and now I need to find the x-intercept. So my x-intercept is going to have me select the second option. X-intercept and 0 are synonymous. They are the same thing. So here, I'm just going to hit enter again. And instead of hovering over the vertex this time, where I need to hover is around the 0, where x is equal to 0. Again, if you look on my key press history right now, you'll see again exactly the key presses you should do in order to be successful for finding the vertex. So I'm hovering over the vertex. Once I've hovered over the vertex, I go 1, 2, 3 to the left. Then hit enter. Go back to where I started by going right 3, and then go 3 to the right again. Hit enter. And then we want to try and guess what the 0 would be. So it should be somewhere around 2.6 seconds. At least that's what it looks like right now. I'll hit enter. And I was right. It actually is around 2.6 seconds. Now, I want to talk about this 1 times e to the 11th deal right here. E to the 11th means that it's scientific notation and it's a very small number. So this is a decimal place with a bunch of zeros in front of it. To be exact, in this case, there would be 10. So we know here that we don't really have to worry about this value because it is pretty much 0. So if you don't get 0 for y, just know that that value is pretty close to 0 and that you don't have to worry about it. The last thing that I want to go over is if you are asked, if you're given a y value and you need to find an x value, the trace feature doesn't allow you to substitute y values. So what you need to do is create a second equation to find that value. Okay? So what we're going to do is we're going to say, okay, what's our height? Like for letter H, it says that you want to find it when it's 20 yards in the air. So we're going to make a second equation where y is 20. And then we'll hit graph. And we see that we have 2 intersection points here at which both graphs cross. To find the x values at those points, what we're going to do is hit and go back to the calculate menu. Second, trace. And instead this time, if we're trying to find an intersection point, we're going to hit intersect. And intersect is actually the easiest function to deal with because all you have to do is hover over the intersection point and hit enter 3 times. So the first place that it is 20 yards in the air is 0.5 seconds. But we also know that it has to come down, and so we need to find the other intersection point. So we're going to do the same process. Hit second, trace, and select number 5, intersect. And instead this time we're not going to hover over the first intersection point, but we will now hover over the second. Hit enter, 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 and you see that the intersection point for the second one is 2 seconds. Now, just as a reminder for those of you that might not have remembered from class, in your Am I Ready, number 3 and number 4 did not have equations that were printed properly, so I'm printing them onto this video as well, just in case you need to get them at a later time. If you have any questions, you know where to email me, cvokes@d94.org.